Hi there, Mr. Sutton here with the AB Calculus 5.8 Extra Practice Number 1 solutions on FTC derivatives of integrals. On this problem, we're trying to take the derivative of this integral function here. So using our FTC, we're just going to plug the upper limit in for the dummy variable and use the chain rule. So we're going to have 2e to the 2x plus 3 times 2. And if we want to clean that up, I guess we could write 4e to the 2x plus 3. On this one, to take the derivative of this integral, we're just going to plug this upper limit of x squared in for t. So this will be negative x squared squared plus 4 times a chain of 2x. And cleaning this up a little bit, we can write this, let's see, this is negative x to the 4th plus 4, so this would be negative 2x to the 5th plus 8x if we distribute that 2x out there. For this one, to take the derivative of this integral, we have to plug our upper limit into the dummy variable. So this is just going to be negative 2 times x squared plus 1 times a tail of 2x, the derivative of x squared. And then multiplying all this out, this is going to be, let's see, negative 4x cubed plus 2x. To take the derivative of this integral, we're going to plug our upper limit in for t. So this is just going to be negative 2x to the 1/2, and that's it. To take this derivative, we're just going to plug our upper limit of x in for our dummy variable t. So this is just 3e to the x, and there is nothing else on this one. For this problem, to take the derivative of this integral, we're going to take our upper limit, plug it in for that dummy variable t. So we'll have 2x cubed to the 1/2, but then we'll have to multiply by our tail of 3x squared. Cleaning this up a little bit, we've got 2 times 3 is 6, and then we've got, let's see, this is going to be x to the 3/2 plus a 2 out there will be 7/2, so 6x to the 7/2. For this one, we're trying to take the derivative of this integral, so we're going to plug our upper limit of x squared in for all the t's, and then multiply by the tail of 2x. So we'll have x squared to the 3rd minus 10x squared squared plus 33x squared minus 32. Again, all times that tail of 2x. And now if we wanted to clean this up, this is x to the 6th times 2x, so 2x to the 7th. This will be 20 minus 20x to the 5th plus 33x, or 66x to the 3rd, and this will be minus 64x. For this one, taking the derivative of this integral with x as an upper limit, we're just going to plug the x in for the dummy variable. So this is just going to be 3 over x squared. For this one, we're trying to take the derivative of this integral. So plugging our upper limit in for the dummy variable, we've got 2 over quantity, or 2x minus 2 quantity cubed. But then we're going to have to multiply by the derivative of 2x, which is 2. So when the dust settles, we end up then with 4 over 2x minus 2 quantity cubed. For this one, we're taking the derivative of this integral with x squared as the upper limit. So that'll end up being, if we plug that in for the dummy variable, negative 2 cosecant of x squared cotan of x squared times that tail of 2x. Cleaning this up a little, we've got negative 4x and then the rest of that stuff. For this one, we're taking the derivative of this integral with x as the upper limit. So we'll just plug the x in for the dummy variable. That just gives us x squared plus 2x plus 3. For this one, we're taking the derivative of this integral with x as the upper limit. So we'll just plug in x for our dummy variable. That's 2x plus 1 times a tail of 1, but who's going to write that? For this one, we're trying to take the derivative of this integral with x as the upper limit. Since it's just x, we can just plug that in for the dummy variable and not worry about a tail. So that's going to be negative secant x tan x, and that's it. On this problem, we're given a function defined as g of x equaling this crazy integral function here. We want to know on which of the following intervals is g decreasing. So if I'm asking about whether g is increasing or decreasing, I'm asking really about g prime. So we need to take g prime here. If I take the derivative of both sides of this equation, On the right side, since I'm taking the derivative of an integral with an x in the upper limit, I'm really just substituting x for all the dummy variables. So this g prime is going to come out to x cubed minus x squared minus 6x all over square root of x squared plus 7. And there's no tail to worry about because the derivative of x here is just 1. So this is what I'm trying to zero out now. Now, since this was a no calculator question, we have to just factor, do some sign analysis, and do it the old-fashioned way. So let me factor my numerator now. I know I can take an x out of all those, and if I had x squared minus x minus 6, I can factor that into x plus 2 and x minus 3. So figuring out what zeros this out, definitely 0, negative 2, and 3. And if you think about the denominator, well, there's really no way to zero this out because x squared can only be positive, so there's no way to get rid of that positive 7 down there, or to make this negative at all. So it just comes down to 0, negative 2, and 3. Let me put those on a number line. So I've got negative 2, 0, and 3, and this is my g prime number line here. So doing a little sign analysis, we've got, let's see, something to the left of negative 2, like negative 3. That's going to give me a negative, and another negative, 3 negatives. And the denominator can't help but be positive because square root only gives us back positive numbers. So it's all about the numerator. That comes out negative overall, 3 negatives. Now let's test out negative 1 between negative 2 and 0. So that's a negative, a positive, and a negative. 2 negatives gives us a positive. Testing out now 1. That's a positive, and a negative. 1 negative makes all of it negative. And then if I test out something like 4, everything comes up positive upstairs. So that's positive. Decreasing intervals, that's going to be where we have a negative g prime. So that would be from negative infinity to negative 2, and from 0 to 3. So that would end up being then, let's see here. So this, they have it in old school notation. So this is going to really be just x is less than negative 2, and we also have 0 less than x less than 3. So that the closest answer here is choice A. Now you notice they have the equals here, whereas I didn't really include anything on my intervals. Just remember that with increasing, decreasing intervals, if there are no discontinuities or places where the function's undefined, you are actually allowed to include the endpoints. On this problem, I'm given this integral function, and I want to know an expression for the derivative of this. Since I'm just taking the derivative of an integral with an x in the upper limit, I'm just going to plug the x in for that dummy variable in there. So we've got tan of 5x, secant of 5x minus 1, times a tail of just 1 because we're just taking the derivative of x. So then that ends up being answer choice D. For this problem, I'm trying to take the derivative of the integral from 0 to x of cosine 2 pi u du. Since I'm taking the derivative of an integral with x in the upper limit, I just plug the x in for the dummy variable, which is u in this case. So we've got just cosine of 2 pi x for our answer on this one, and that's going to give us choice D.